Hey gang, this video is going to delve off into the next chapter for which we have not covered these notes, but I'm going to go ahead and start because the first part of this has to do with graphing lines. And because that's the material that we've been covering, I want to go ahead and cover this because it will serve two purposes. It'll jumpstart us and get us into the next chapter on solving systems of equations, but also give you a little bit more practicing of graphing lines. So I'll go through the notes. We're only going to cover about this first page and half of the next page. And I also have sent this in your notes as a PDF file. So if you'll print this with the PDF file, your graphs on it should show up just fine and not be squished or misshapen by the fact that it's in just a Word document. So this one should print just fine for you, and you'll be able to do the graphs on the paper on the notes that I give you. So just make sure that you have your notes with you. So the only difference in what we're having here is what's called a system of equations. So it's a set of or a collection of equations that will work together to determine a solution. The simplest one is what we're going to work with, and you're going to get two equations and you're going to have two variables. Now basically what we're going to be looking for as a solution for this quote system is a place where the two lines would cross. What would they have in common? And so here's two equations that you're given. Both of them, notice, are already given to you in slope-intercept form, so they would be easy to put on a graph. So on this top one, you would know that the b value is 0, -2, and the slope number would be 3/1. So you would be able to graph that one. So if we look at our sample here, our 0, -2 would be right here, and our slope is positive, so we can go up 3 and over 1 and we'd have a dot right there, or we could go down 3 and to the left 1 and we'd have a dot right here. So this top one would be the blue line that's on this graph. That's one that's leaning in the positive direction. Then if we graph the other one, the intercept would be 0, -6, our starting point, and the slope value on this one would be -1/1. So we know this one's going to have to lean to the left, so this would be the green line that's graphed on your page. The -6 means it would start here, and the slope goes down 1 and to the left, down 1 and to the left, up and to the right. Now, one of the things I talked about in class the other day was the more dots you put on the graph, the more accurate it is. It's more important in this situation because we're going to be graphing two lines together, and we're going to then be looking for the spot where they cross. So the only thing that they have in common is that dot, and so that is our solution. It would be at -1, -5. So a solution for a system. Okay, the solution for a system, if they cross, because remember not all lines cross, so if they intersect, that solution is going to be an ordered pair. So that means you would have to identify the point where they cross. Alright, so it's a point. So you're going to have to graph two lines on the grid on your homework, and then after you graph the lines, it's going to ask you to, it's going to say check your answer, and they'll tell you if it's correct or not. And then they're going to ask for the answer as a solution. So if the lines cross each other, they're going to be asking for that dot and label that point as your answer. Now it always has to be written as an ordered pair. It has to be in parentheses when you write it in the blank. So you're going to have an ordered pair. Now this point is the place where the two lines intersect, and it solves both equations. So it belongs to both equations, so it basically solves the system of equations. Now you can take and confirm that this is true if you plug those numbers back in. So if you go to the first equation and you plug in -1 for y, so I'd have y equals 3x minus 2. So I'm going to plug in the negative 5. I'm sorry, negative 5 for y, 3 times negative 1, and then minus 2. So is that going to be a true statement? Negative 5 would equal to negative 3, and a negative 2 would be negative 5. So I know that this point would be true for this line. So then if I want to see if it would be true for the other one, I would do the same thing. Y equals negative x minus 6, and I would test it to see, is negative 5 equal to the opposite of whatever the x number is. So you have to have a negative in front of the x and then plug in the x and then minus 6. So in this case, this would now be positive 1 and negative 6, and yes, negative 5 would equal negative 5. So if they ask you to determine if this point is a solution, then you take that point and you actually just plug in the x and y values and see if it comes out to be true. So sometimes that's all they're asking you. Is this a solution for this system of equations? Now, if they didn't give it to you on a graph, then you would just go back to the equations and test it and see. But we also know this, not all lines intersect. So as we're doing systems of equations, there are possibilities that can be different, give us different looks. So we have case 1, which is like the one we just did, and we would have one dot, and on this one, let's see, this would be negative 2, positive 1. So this would be negative 2, comma 1 would be our answer for this problem. Based on this picture, the only place they cross is that dot. So your solution, okay, go ahead and write that in. The solution for this problem is negative 2, comma 1. Okay, so now here's my other possibility. Sometimes lines will never touch each other. Those are parallel lines. So the solution here, our solution is looking for the place they cross. So if they never cross each other, then our answer just says we have no solution. There is no solution because they don't cross. Now, you can use that symbol, and sometimes on your homework, you'll have that little symbol there as a choice for answers. Or they will say there is no solution, and you'll have a little drop-down menu to click that on. Now, here's the other case, and this one looks like there's only one line. But what it is sometimes, and I always have used this example in the past, but it doesn't work so much anymore, because used to be on Amburn Street, right out there next to the school, in front of the DPS office, we had an asphalt road, and it invariably had holes in it because it had trees in the middle of the road, and it would suck the water out and create holes. And then they would have to come back about once a year, and they'd have to pay that asphalt. So what they did is they laid the road. The original road was there, but they came with another layer, and they just laid it right across the road that was already there. So it's really one line laying on top of the other line. Now, if we're looking for the places that they have in common, and we have one line stacked on top of another line, they have many, many places in common. So every place where the lines touch each other would be a dot on the graph or a point. Well, we can't write all of those points, so all we say here is that it has infinite solutions. And we don't really have a number for that. We don't call it infinity. It just says we have more solutions than we can count. So if we have the situation where the two lines, the two equations, turn out to be the same line, then we just say it has infinite solutions. So when you have a graph and you have an opportunity, and you're going to have this on the homework, there's only 4 problems on this homework that has this section. I believe it's number 1 and 2, and then number 9 and 10. Those will be problems that are on graph, and so you will have, for this homework, you can go ahead and be working on those 2 problems and do them by graphing. So that, and then the later ones we can get. So now you can actually have a little extra graphing practice. Now down here is some terminology. I don't believe that any of the terminology is a question in anything that's on the homework. But the terminology is going to be related to things that you might do in college algebra, so I'm going to go ahead and talk about it. The first graph that has an absolute intersection spot, if we have one answer that's an intersection, we call this an independent system, okay? So this one right here is number 1. It's an independent system. Each line is operating independently of each other. So number 1 fits this. Then in this case, where we don't have anything that crosses, so we don't have anything in common at all, it's called a no solution for your answer. But if you describe what the system of equations is, it's called an inconsistent system of equations. So this is just a description of what it looks like, okay? It's called an independent system if it has one dot for an answer. If it has no solution, it's inconsistent. Basically, inconsistent is like when somebody is going to be your witness and they tell one story one time and another story another time. Their information is basically inconsistent, so it's of no help to you. So this is kind of a description of what happens here when we're looking for where they cross and they never cross. They're really an inconsistent system and it has no solution. So when you ask for solution, your answer will be either the words no solution or the symbol. So then when we go to this last one, this system is called a dependent system. So this one goes with this picture. And it's basically called dependent because one is dependent upon the other. They're laying on top of each other. And the solution would actually be the whole line, and so we can't name each individual dot, so we call it infinite. So here's some new terminology. A system of equations that has one solution is independent. If it has no solution, it's called inconsistent. And if it has more solutions that you can count, and infinite solutions, it's called a dependent system. So that's just some description and terminology. On the homework, on these 4 problems, they're going to be asked to do them by graphs. So really all you're going to be doing is graphing 2 lines for number 1 and see where they cross. 2 lines for number 2, 2 lines for number 9, 2 lines for number 10, and then you're going to see which of these 3 systems does it fit. And then if it has a solution, you're going to write it. If it doesn't cross, you'll write no solution, or you'll click on the box for no solution. And if it's one line laying on top of the other one, if it's one line laying on top of the other one, you actually have to graph one line on top of the other. You have to graph both of them before it will tell you that it's correct. And then your answer will be the drop-down box that says infinite solutions. So let's practice doing a couple of things on graphing. So get the page that has the graphs on it, and then we're going to graph the lines. Now, notice on this first one, the lines are not in slope-intercept form. So what you need to do, what you'll want to do is change this to slope-intercept form, or on this one, you could even use the intercepts if you wanted to, because all these numbers can be simply divided into 12. Because the 3x would divide, the 3 would divide into 12, the 4 would divide into 12. So you could do ordered pairs on that one that would just be the intercepts. So let's just go ahead and do that for practice right now. So I'm going to make my ordered pairs. So when you see that 12 will divide by both 4 and 3, that would be a good one to do intercepts on. So whatever that number is. So if I let x be 0, then I'm going to cover up the x, and I'm just going to have negative 4y equals 12. So I'm going to divide by negative 4, that'll be negative 3. So that's one dot. Then I'm going to do and cover up the y, and I'll have 3x equals 12. So my y would be 0, then my x value would be positive 4. Now be careful with your signs. Okay? So now I'm going to go ahead and draw some lines on the graph here, and I'll just do it across all of them. Okay, so here I have my y-axis. Here's a y-axis. Y'all might want to do this before you even start working the video. Okay, so on the first one and on your homework, this will be what you have to do. You're going to have to take the first one and get the information and graph it first. So you're going to take and locate that point first. So 0, 3, -3 would be here. You're going to click a dot. First, be sure to click line as you get started. And then you're going to go to 4, 0. So I'm going to go positive 4, 0 would be right here. And then on your graph, you're going to click that line. And once you finish it, it'll turn blue on the graph. So there's your line. Okay, then we're going to go to the next one. Well, 3 is not good. This one would not work out well trying to use intercepts. So I'm going to go ahead and solve for y. I'm going to subtract 5x and get this in slope-intercept form. So I get y equals negative 5x minus 3. Then my b is going to, my graph is going to start at 0, -3, and my slope number will be -5/1. So here's an example of one of the things I've kind of talked about in class. If I start my graph down here at 0, -3, and I try to go down 5, it doesn't fit on my graph. So what I can do is I can change this and make it positive on the 5 but negative on the 1, and then I can go up 5 and 1 to the left. Because it's negative, I know it has to lean to the left, and then I can draw my line. And on your graph on your homework, you're only going to have 2 dots, but you got to have 2. So then there's my place where they cross. On your homework, you're going to click, check it, check the answer and see if the graphs are right. And then if the graphs are right, they're going to give you another place, and you're going to look down and you're going to fill in the blank and draw parentheses, and you're going to locate that point. So this point would be at 0, -3. So this one has a definite point where that crosses. Okay, so this would be case 1. This would be called an independent system. Okay, now if we go over here to this one, my top equation is already in slope-intercept. So my b is going to be 0, 5. The slope number is the -1 that's in front of the x, so -1/1. So I'm going to put that information on my graph. I'm going to graph that first line. So you'll take your graphing tool on your online homework, and then you're going to click on the little line space, and then go 1, 2, 3, 4, 5. Put a dot right there, and then count. Go down 1 and over 1. And when you put the dot right in the right place, your line will be straight for you. Now for me, I'm just going to go ahead and add a few more dots, make it look a little better. Because when you're doing it on paper, if you're off by just a little bit, your lines won't maybe cross in a good place. Okay, so here, what am I going to do? I'm going to say I need a y by itself. So I'm going to subtract x. So I get y equals -x minus 1/2. Okay, my b value is going to be a point 0, -1/2. Now that's okay. I can find a half pretty well. It's going to be between 1 and 0. So I can find the half on that. And then my slope value is going to also be -1/1. Well, we learned something in the last chapter, in chapter 3, about slopes. If the slope values are the same, I should know already that these lines are going to be parallel, because we learned that parallel lines have the same slope. So I'm going to go find 0, -1/2. 0, -1/2 would be right about here. So now when I go down 1, I'm going to have to jump to the middle of that square and over to the middle of the square here. But I'm still going down 1 and over 1. My dots just end up in between. But you can see when I connect those dots, it's going to be a parallel line. So what do I write as my solution? Where do they cross? Well, they don't cross. So my answer here is no solution. Alright, on your homework you'll have a drop down menu, and your choice then, because they don't cross, would be this. Now if they cross in some wicked space, when you go to check it, it's going to tell you that the lines are wrong, so you need to go back and look at the one that check them both, clear it, and redo it is the easiest way to do it. Okay, on this last one, I'm going to try to get y by itself. So let's see what happens. On this one, I'm going to move the 3x over. So that would be minus 3x minus 3x. So I'll get y equals negative 3x minus 2. Alright, so this one's going to be b is 0, negative 2, and your slope is negative 3 over 1. Alright, so now I'm going to go down here and start at negative 2. 0, negative 2 is my starting place. Go down 3, 1, 2, 3 over 1. And it's negative slope, so I know my line is going to have to lean this way. So with that count, that looks right. If I go up 3 and over 1, I get a little bit better line out of it, so that's why I'll add more points. So there's one line. Then I'm going to have to take this one. Now this one you're going to have to be careful on, okay? I'll put a star on that. Because when I move the 3x, I'm going to be left with negative y, so make sure that negative's there, equals negative 3x minus 4. Now when I divide, I'm going to divide through by negative 1. And so all it's going to do is change my sign. So I end up with y equals positive 3x and positive 4. So be careful on this one, and that's a place where you're going to make a mistake. I hope not, but sometimes we do. Okay, so this would be 0, positive 4, and the slope number is going to be positive 3 over 1. Well, if the slope numbers are different, then I know the lines are going to intersect. So be careful as you draw them. 1, 2, 3, 4, and my slope is going to go up 3. Uh-oh. I don't have enough space to go up 3, so what I'm going to do is I'm going to reverse this, and because if I put them as both negative numbers, the negative divided by negative will still give me positive. So I'm going to go down 3, but I'm going to go 1 to the left. Down 3 and 1 to the left. So my lines are going to cross. So there's where they cross, and then I might look for my point. So my spot where they cross is right here, so I'm going to label it. It would be negative 1, positive 1. So negative 1, 1 would be the answer. On your homework there'll be a drop down menu. Now it's an interesting situation when you have one that has infinite solutions. So just for a practice, I'm going to show you on the back what would happen. If you have an infinite solution, you're going to have equations that kind of look weird. You might have y equals 2x plus 1, but then you might have an equation that's like 2y equals 4x plus 2. Well, if you divide the second equation by 2, because they'll all divide by 2, notice what happens. You'll end up with y equals 2x plus 1. So when you get an infinite solution problem, what it means is you have the exact same equation. They're just going to look different when you start, but when you change them, they're going to end up being the same line. And so on your homework, the one that I saw as an example, you have to actually graph both lines. So I'm not exactly sure how it's going to happen, but once you get it to y equals form, when you get it into slope-intercept form, you're going to see that both of these are the same. You've got to put the line on the graph. So graph it starts at 1, it's going to go up 2 and over 1, and you might just only have to graph one line. I'm not just exactly sure on that. So once you graph that line, if you click it and it says you're supposed to graph 2, well then you'll graph 1 right back on top of it. And then in your drop down menu, it'll give you a choice, and your choice will be infinite solutions. So this part of our lesson for 4.1 gives you some practice on graphing, because you really need to work on practice by getting into slope-intercept form and then graphing and moving them around so that you can do it correctly. The biggest problems will be if there's a negative on a y value here, because sometimes you mess up your sign. You just have to be careful. You have to be a little more tedious. So the one thing about doing this on video is you can stop it and start it again and look at it and go back and look at it again. So if you get into your homework, just kind of keep this on the side where you've taken the notes, and you can go back and look at them. So this should help you get through 4.1. I'm probably not going to have time to teach this in class on Tuesday, so that's why I'm teaching it now, because it's related with graphing, and that's what your next test will be. It will cover all the graphing stuff, and this will not be on it yet. So in class on Tuesday, we'll cover the substitution problems, and we'll cover the rest of the page, because this would be 3 pages long. So we'll cover the algebra parts of doing this. So I hope you have a great weekend, and I hope you understand what we're doing here. See you later. Bye.